Hello, my name is Mark, and I'll be talking about diagram 3 and why it doesn't work correctly. Here's a look at diagram 3. Now it's hard to focus. Shows one no-step isolation transformer there and 200-watt light bulbs connected in series. And also, B and C is connected in series to make 240 volts between A and D. But C and D measure 120 volts and A and B measure 120 volts. Now here, I'm using two 10.5 watt LED bulbs, which take about 98 milliamps, or 0.098. And I got hooked up to two transformers instead. They're 240 to 240 volt no step isolation transformers, and they're hooked up in parallel. Yeah, hooked up in parallel, because there's two, the diagram here, there's two parallel branches, A and B and C and D. The C and D is isolated from E and F because they're electromagnetically connected. Now the problem is it doesn't work correctly, gets the right voltage, but it draws too much current from the wall or the source. And that's because there's 240 volts present at the secondary coil, or C and D. During 1 second, it alternates 120 times, or 60 cycles per second. So this is 240 volts, and then when it changes direction, it's 240 volts up here. I think that what does, it causes electromagnetism to go backwards to the primary coil, like a backlash or something. And I think the primary coil draws more current from the wall outlet to somehow cancel that electromagnetism or induction, or whatever it's called. Now I'll turn it on and show you the voltage and current measurements. There, I've got light. Here's the two bulbs connected in series, but they're not getting 98 milliamps. They're getting about 80 some milliamps, almost 90 milliamps. And here I got the voltmeter hooked up, and it's on the 250 volts scale, and you can see that the red line there right about there is almost at about 240 or a little over. And here the black probe and the red probe are at A and D. Now if I just take the red probe over there and hold it steady, now it measures 120 volts. And it'll be the same over here, over there, yeah, the secondary coil. Now just have a look at You can read this here. They're custom-made transformers. Now for the current measurement with this clamp-on meter. Set it to 40 amps and at AC. Yeah, and then down here just got to split the wires here and stick the clamp in there and see what it measures. There it is, 0.07, 0.08. Oh, geez, lower than I thought. Let's say 0.08. Now, if the circuit works right, the current measurement coming from the wall outlet should be 0.04 or 0.035 or 40 milliamps. Now we do the same thing here where the cord is split. There it is, and it is 190 or 200 milliamps. It's different from one I measured before, a little higher. Well, it's supposed to be 198 milliamps to run one of these bulbs. But with two bulbs using the same current. So, maybe there's something going on here, all right. Okay, that's all I want to talk about, except there's the two parallel connections there, connected to the extension cord. And here's this series connections to the cords for the two light bulbs. Just using alligator clips to test it out. Okay, I guess that's all I need to talk about that. Okay, thanks for watching.